Importance of FRP fiber reinforced polymer manufacturing techniques in production lies in how these determine the quality, performance, cost, and efficiency of the final composite product. FRP materials are widely used in industries such as aerospace, automotive, construction, marine, and wind energy, and the chosen manufacturing method directly impacts their suitability for each application. A well-chosen process ensures consistent mechanical properties and long-term performance. Efficient process selection balances production speed, material efficiency, and cost-effectiveness. This presentation is a high-speed tour of all the manufacturing techniques used in FRP composites industry. Hand layup process is suitable for low-volume production and has lower initial equipment costs. It is best suited for paneling in all the industries, as it allows for creating complex or customized shapes. Spray molding uses a spray gun to simultaneously apply chopped fibers and resin onto a mold. It creates large, flat sheets for applications like doors and grills. Compression molding is useful for automotive industry as it produces products with high surface finish. In resin transfer molding, RTM dry fiber reinforcement is placed in a closed mold, and then liquid resin is injected under pressure to impregnate the fibers. Aero and automobile industries rely on these techniques. FRTM is most popular and convenient method for manufacturing large wind mill blades and chip hulls. Manufacturing techniques like filament winding and weaving preforms are optimized for continuous fibers and high-performance composites. Industries use these in aircraft parts, prosthetics, and pressure vessels. Pultrusion is an automated, continuous process where fibers are pulled through a resin bath and a heated die to form a specific shape, such as profiles, rods, or bars. High-precision FRP manufacturing techniques are flashed on the screen. These have high degree of repeatability and suited for aerospace and high-end applications. FP is a high-tech, automated process used in the aerospace industry. It requires a significant capital investment for the machinery, but reduces labor and material waste. Vacuum bagging process is frequently used in aerospace industry. It is relatively less expensive than VARTM and LRTM techniques. Prepregs ensure high performance, precise control over resin content and curing. Recent advances are aimed at out-of-autoclave curing to reduce manufacturing costs and reduced energy consumption. Use of prepregs in combination with autoclaves guarantee defect-free components that are essentially needed for primary aircraft structures. Use of prepregs in out-of-autoclave processes reduces cost but require excellent manpower skills. Centrifugal casting and sheet molding make high-precision and top-quality products at an elevated price. 3D printing, also known as additive manufacturing, is an added innovation for manufacturing high-quality fiber composites. This process boasts of rapid production rates with consistent quality control. Compression molded parts in BMC are widely used in electrical industry. FRP products combine lightweight properties with high strength, corrosion resistance, and design flexibility, making them ideal replacements for traditional materials like steel and aluminum. The industry also presents opportunities for innovation and sustainability, as modern manufacturing techniques reduce waste and emissions. Technology education and mentoring center. While advocating the cause of fiber reinforced composites manufacturing is always available for guidance to young entrepreneurs.